For question 1, we're testing to see if there is a difference between the means of two different populations. And our first population is male high school students, and our second population is female high school students. You can read more about testing the differences between population means here. And in these examples we're going to do first, we know the population standard deviations, and the samples are independent, which just means that the sample selected from one of the populations is not related to the sample selected from the second population. So looking at this problem, you can see we do know both of the population standard deviations. They're told to us. And the 43 male high school students in our first sample have nothing to do with the 55 female high school students in our second sample. So the samples from each of the two populations are not related to one another. Like with all hypothesis tests, we need to identify our null and alternative hypothesis. Here the claim is that male and female students have equal exam scores. So that's our claim. Our claim here of equality goes with the null hypothesis, so that the mean from one population being equal to the mean from the other, that is our null hypothesis. And the alternative hypothesis is the complement of that, so it'll be not equal to for our alternative. For part B, the critical values with the rejection region, that's all based upon what alpha is. And when we're working with problems like this where we know the population standard deviation and our samples are independent, we can use the normal distribution. And so we're going to use that with our alpha of 0.01 to identify the critical values. So I'm coming over here into Excel looking at identifying the critical values. Since our alternative hypothesis is not equal to, this is a two-tailed hypothesis test. So 0.01 total would mean that there is 0.005 in each of the tails, half of 0.01 in the tail. And so we use this formula in Excel, gives us the critical value associated with 0.005 in one of the tails. So then by symmetry, use those same digits, negative and positive, to get the critical values marking both sides of the distribution, marking a total of that value, 0.01, being split between the two tails of our distribution. And next we're going to find the test statistic for our samples. And if it is past the critical values into the rejection region on either side, then we will reject the null hypothesis. And to find the test statistic, we're going to use this formula here. And the bottom part here is actually this formula right here. And so when I work this out, I'm going to calculate this part separately. That's the value that goes on bottom. And then on top, we're going to subtract the two sample means from one another. And then the population means are set equal to each other. So this value is 0. So it'll basically just cancel out. So on top, we're just subtracting the sample means from one another. And on bottom, it's this calculation here. So coming into Excel to calculate the test statistic, I'm first going to do the bottom part of that calculation. And you're doing the same thing with each of your sample data from your two populations. You take the population standard deviation and divide by the sample size. So you do that with sample 1, and population standard deviation divided by the sample size for sample 2. And you add those two values together and take the square root of the entire calculation. That gives you the part that goes on the bottom for your calculation of your test statistic. And on the top of it, all it is the sample mean subtracted from one another. And so do that subtraction on top, divide by that calculation, and you get your test statistic for your two samples. And since that value, it's not further left than our left-hand critical value, it's not greater than our right-hand critical value, it is not in the rejection region, we're going to not reject, fail to reject the null hypothesis. And our claim here, recall, was that male and female students have equal exam scores. And since there was not enough evidence for us to reject the null hypothesis, it means there's insufficient evidence to reject the claim. And the level of significance was what was listed here. So although our samples from each of the populations definitely had different means, different mean exam scores for the male and females, they weren't far enough apart and they weren't different enough for us to assume that the entire populations of all the males and all the females actually have a different mean exam score. Number 2 is similar to number 1, so I'll go through it a little bit quicker. Our claim here is that the mean home sale price from city A is the same, it's equal to the mean home sale price from city B. So that's our claim. The statement of equality here is going to be the null hypothesis always, so the two means being equal to each other, that's our null. Our alternative then is the complement of not equal to. So again, like with number 1, our null hypothesis is our claim. So we have two populations, the home sale price in city A and the homes in city B, and we know the population standard deviation of each of these populations. And the samples are independent of each other. There's no relationship between the 20 homes selected in each city. So we can use the normal distribution. We're going to be using this formula right here to calculate our test statistic. And we'll be using the normal distribution also to calculate the critical values. And our problem alpha was 0.01. And since this is a two-tailed test because our alternative hypothesis is not equal to, we want that 1% split between the two tails. So half of 1% is what we would enter into our equation here. We're using the normal distribution, and we get our critical values. And so the positive and negative of that are our two critical values. If you're further left into the tail or further, or you're greater than the right end critical value, you're in the rejection region. Let's see if our test statistic is in the rejection region. First, calculate the bottom part of our formula here, population standard deviation divided by the sample size. We're going to do that for each of our populations here and add then the two results together. That whole entire calculation, you take the square root of it. That's what goes on bottom. And on top, we're finding the difference between our two sample means here. And that is our test statistic. 1.8 is not greater than 2.576. And since that test statistic is not in the rejection region, we fail to reject the null hypothesis. And recall that the agency's claim was that the mean home sale price from each of the cities was the same. And the null is our claim. We're not rejecting the null. There's not enough evidence to reject the claim. And number 3, we're looking at two equivalent ways to say the same thing. Saying the means of two different populations are equal to each other, that's equivalent to say you take two equal values and subtract them, you will get 0. And you can also see this equivalence through algebraic manipulation. If you subtract the mean of the second population from both sides of this equation, on the left side you'll get the mean of the first population, subtract the mean of the second, and on the right side you would just have 0.